Good morning. So I am Dr. Ramya Swetha from Hydraulic and Hydraulic Machineries. Today our topic is dimensional analysis. Coming to the dimensional analysis, it is one of the important thing which we have to understand for designing and analyzing the such huge hydraulic machineries and structure for understanding the hydraulic structures as well. So for these are the some of the various references which may helpful for better understanding of the dimensional analysis thing. So in this, which we are going to understand, actually dimensional analysis is a huge one, but once you understand, we may apply n number of practical applications. So in that particular thing, so now we are going to understand as per the requirements. So these are the things, these are the topics which we are going to cover in overall these dimensional analysis. In today, dimensional analysis, dimensionless numbers, and what are the various methods which we are going to apply in this dimensional analysis. It is dimensional analysis, it's a pure mathematical technique, complete mathematical technique to establish a relationship between the physical quantities which are involved in that particular fluid phenomena by consider their dimensions. So based on their dimensions, which we are understanding the mathematical technique which establishing the relationship between those physical quantities involved in that particular fluid phenomena. So in this, basically based on the fluid phenomena, we are going to understand based on the fluid, considering their dimensions, we are creating or we are getting the technique and we are understanding the relationship between those physical quantities. In dimension analysis, from a general understanding of fluid phenomena, we first predict the physical parameters that will influence the flow, and then we group these parameters into dimensionless combinations which enable a better understanding of the fluid phenomena. This dimension analysis is practically helpful in experimental work because it provides a guide to those things that significantly influence the phenomena. Thus, it indicates the direction into the experimental work should go. So, in this analysis, what we understand, we are understanding the physical parameters and those influence on that flow, and how we are grouping those into the dimensionless combinations for better understanding of the flow phenomena. So practically it is very helpful in experimental work because it provides a guide to those things that significantly influence the phenomenon. So very significant influence on the phenomena. So this is the overall understanding about the what is dimensional analysis. It is a pure mathematical technique between relationship between the physical quantities involved in this fluid phenomenon. So coming to the dimensional analysis, which refers to the physical nature of the quantity and the type of unit used to specify it. So for this, the first thing, so distance has distance, that is in terms of L. Whether it is length point of view, whether length is also a distance, depth is also a distance, width is also a distance, thickness, all these are all comes under that comes under this L. So coming to the area is nothing but sometimes it may be length and breadth and depth and length, depends upon its requirement. So now length, not only length is comes under distance, breadth is also in terms of distance. That's why L into L, that is equal to L square. So this is the dimensional unit for area. See, like this we have to understand all the dimensions. Coming to the volume also length into breadth into depth. In terms of dimension analysis, this volume is equal to length is in terms of L Breadth is in terms of L. Depth is also in terms of L, because all these three are comes under distance. All these are comes under distance. So this is equal to L cube. This is the dimension number. This is based on the dimension number. Time. Times comes under T. Speed. So based on the speed is equal to, now comes under, speed is equal to distance by time. How we calculate speed? Speed is equal to distance by time. So distance is equal to L, this is equal to T, speed dimension unit is equal to L T to the power of minus 1. L T to the power of minus 1 is the speed dimension number. Like this, we are understanding the, based on their formula, we are converting into as a dimension number. So in this, what are the various applications are involved in this dimension analysis comes for that. So development of an equation for fluid phenomena, conversion of one system of units to another, reducing the number of variables required in an experimental program, develop principles of hydraulic similitude for model study. So these are all comes under some of the applications which we are understanding using the dimensional analysis. These are the applications which we are going to use in dimensional analysis. So in this principle dimensional, so dimensional reasoning and homogeneity and principle of dimensional homogeneity, the fundamental dimension and their respective powers should be identical on either side of the sign of equality. And dimensional reasoning is the predicting on the preposition that for an equation to be true, then both sides of the equation must be numerically and dimensionally identical. To take a simple example, x plus y is equal to z when x is equal to 1, y is equal to 2, z is equal to 3. It is clearly numerical true, but only if the dimensions of x, y and z are identical. So, so how we are understanding? So, x plus y plus z is equal to z. So, x is equal to 1, y is equal to 2. So, then z is equal to 3 is right. When the dimensional identical is required. So, for example, x comes under elephant, one elephant, and y comes under 2 aeroplanes, 3 days. Is it right? No. So, x comes under days, y comes under days, z comes under days, only the equation is right. So like that we have to understand the dimensional units. So the principle of dimensional homogeneity also, the equation only dimensionally homogeneous terms having the same dimensions. Like that we have to understand the dimensional analysis. So coming to the fundamental dimensions, we may express the physical quantities in either mass length time system or force length time system. This is because of the two systems are interrelated through Newton's second law, which states force equals to the mass times acceleration. So based on the second law of motion, through this relation we can convert from one system to the another. Other than convenience, makes no difference which system we use since the results are same. So whatever the system we may use, so that is nothing. So coming to this, first we have to understand the fundamental dimensions are M, L and T. These three are the fundamental dimension. This M comes under mass, like kgs, like that. L, length. L comes under distance. It comes under distance, not only length, whether it is depth, breadth, width, thickness, whatever it may be, comes under distance. In dimensional, these are the dimension units. M, mass, L, T is time. T is comes under time. So these are the fundamental dimensions. So based on the fundamental dimensions, here we have two different dimensions. Those are, we have fundamental dimensions. Fundamental dimensions. Fundamental dimensions M, L, T. Derived dimensions, which are derived from fundamental quantities. So whatever area this comes under derived 2, or otherwise speed, distance by time, that is equal to Lt to the power of 1. These are all comes under derived or secondary fundamental quantities. Fundamental or secondary are derived quantities. Derived quantities. So fundamental quantities are M, L, T. These three are the fundamental quantities. So from based on that, volume, velocity, acceleration, speed, volume, mass, pressure, angle, angular velocity, viscosity, kinematic viscosity, surface tension, force, momentum, power, work energy, distance, temperature, whatever it, those are all comes under based on the fundamental quantities we find out these things. These are all comes under secondary, primary or secondary quantities. So these are the sum of the physical quantities. Those are length, mass, time. These three are fundamental quantities. Remaining all are based on the derived quantities. Comes under discharge is equal to discharge is equal to, and acceleration, force, energy, velocity, these are all comes under derived quantities. These are all comes under derived quantities. So each quantity we may understand under various things. So for example, based on that we are may understanding. So like this, we may derive all the quantities. Coming to the, we may calculate this density. Density is equal to mass by volume. Density is equal to mass by volume. This is the formula. So this is equal to mass by volume. So mass is equal to M and volume is equal to L cube. So that is equal to M L the power of minus 3 is the dimension quantity for density. Similarly, discharge. Discharge is equal to volume by time. That is equal to volume L cube divided by T, that is equal to L the power of T minus 1. Similarly, velocity. Velocity is equal to distance by time. That is equal to distance comes under fundamental quantity, that is L, time, that is equal to L T to the power of minus 1. So like that we are understanding the various quantities. So coming to the force. Force is equal to mass into acceleration. Mass into acceleration. Mass M. Acceleration is equal to, again acceleration. First we may calculate acceleration. Keep it like this. Acceleration is equal to distance by speed time square. That is equal to L by T to the power of minus square. That is equal to L T to the power of minus 2. So L T to the power of minus 2. That is equal to M L T to the power of minus 2. So based on the fundamental quantities, we are deriving the secondary or derived quantities. So based on the fundamental quantities, we are deriving the derived or secondary quantities. So M, L, T, these three are the fundamental or primary quantities, and remaining quantities which are comes under based on these three, those are all secondary and derived quantities. These are the some of the examples how to derive the fundamental secondary or derived quantities. These are the some of the example how we are going to calculate getting the dimensional quantity, physical dimension quantity based on the fundamental quantities. So these are the some of the example. Based on like this, we may calculate all the parameters in terms of dimensional quantity. Angle, there is no dimensional quantity for angle. Coming to the angular velocity, that is equal to 1 by seconds. So seconds is nothing but time, that comes under t to the power of minus 1. So like this. Similarly, each and every quantity which is present in this, it is calculated from, comes under fundamental quantity. So we may derive all these things. So, we make each and every parameter, velocity, speed, mass, and pressure. For example, speed is equal to distance by time. That is equal to, distance is equal to L by time, that is equal to L t to the power of minus 1. Acceleration is equal to speed by time. Directly we like this. So speed is equal to L t to the power of minus 1 by t, that is equal to L t to the power of minus 2. Like that we are going to, for velocity, viscosity also, surface tension, torque, power, work energy, every quantity which is there in this, we are going to get the dimension converted into the physical dimension quantity. So like that we are going to understand this dimension analysis. In further, we will understand how we are analyze by using these two methods, Rayleigh's method and the Buckingham's pi theorem. So in these method, three or four variables only we are going to analyze the 3 or 4 variables. So whenever in that particular equation or in that particular conditions, so 3 to 4 variables are involved, we may use this Rayleigh's method for understanding the dimensional analysis. So more than 3 or 4 members, more than 3 or 4 variables are involved for that particular condition. We are using this Buckingham's pi theorem for dimensional analysis. Buckingham's pi theorem or Buckingham's pi method. So Rayleigh's method and Buckingham's pi theorem, these two are the basic methods for analyzing dimensional analysis. So the involved variables are 3 or 4, we are choosing the Rayleigh's method. So whenever the involvement is more than 3 or 4 variables, that is comes under Buckingham's pi theorem. So these are the things which we are going to understand in our dimensional analysis method. So furtherly, in detail, we are understanding these two methods in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.